Hello and welcome back. In our last video, we introduced nested lists and nested loops to process them. And we used an example of rainfall values across a series of days. So our first index gives us a day, and our second index gives us a particular value for a particular time on each of those days. So for each day, there were 4 different readings at different times across the day. Now we used nested loops to process that structure. There was an outer loop that marched through different days, and there was an inner loop that marched through, for each of those days, the different times that were available. And we can clean this up a little bit. Using a constant set of day values like this makes our program really not very adaptive to different quantities of data. We could improve this. As you see that these are a series of increasing values, you might be thinking, well, a range function is a good way to deal with a range of possible values, and that would be right. But another nice way to do it is to use an enumeration instead. Now, if you remember enumerations, well, they give us the ability to iterate across an index and a set of values associated with that index. So if I just initialize rainfalls here, right, we know from last time that we can go in and say rainfalls indexed by 4, let's say, at item 3. What that'll do is give us day 0, 1, 2, 3, 4. And then it'll say index 3 from that, 0, 1, 2, 3. So that should give us 1. And it does. So that's the element we've just reached into. Now, if we want to look at what an enumeration is, we need to convert the enumeration into a list, and we'll have a look at what the enumeration of rainfalls looks like. Okay, and what it's doing is giving us a pair of values. It's actually a series of tuples. The first tuple contained in here gives us 2 values, 0 and the series of values associated with index 0. Okay, so it's saying 0 at location 0, we've got this 4 values. Next tuple says at location 1, we've got these 4 values, which is right. At location 2, we've got these 4 values, and so on. Okay, so that's what our enumerate function over here does. It gives us the ability to access both an index counter and the series of values in a single go for each of the elements contained in rainfalls. Okay, so that's for each of the days in rainfalls. So I've got that code sitting over here. We're going to print out our header. We do a parallel assignment to get hold of the index into the day and the set of rainfall values, or the list of rainfall values for that day. We print out our title for each of the rows of our table that we want to produce, saying what the day is and with the index. So this is going to be day 0, then day 1, then day 2, and then day 3. And for each of those days, we're going to say for rain in days rain. Okay, so days rain is the list that came out of our enumeration for each of the days, and we can print out our table, the series of values for those elements inside the list. So we can run this, and we get exactly the same tables we had before, but we've got rid of that nasty hard coding of the particular days in question and the particular times in question. So if our meter changes to recording data every 2 hours instead of every 6 hours, our program will still work, and that's a big improvement to our program. Okay, so it now works for any number of days and for any number of rainfall samples per day. A big improvement. Next, we're going to extend our rainfall program in 2 ways. First, it's going to be able to deal with missing data. And second, we're going to calculate an average and total for each day and include those values in the table that we print out. So equipment sometimes breaks down, and rather than just reporting a 0 value when the equipment's broken, it's better to give an explicit code that says this value is in error. So -1 is often chosen as a value that can't occur naturally and signals that some error or breakdown has occurred. So that's what's going to happen now in our data set. So our code is now only going to accumulate or add up the non-negative values. So our pseudocode will look something like this to print out our averages and total for the day. We'll get the rainfall data, we'll print out the heading. For each day, we'll clear the sample counter and total. Okay? And then for each rainfall sample in the day's rain, if the sample is non-negative. So if it's a legitimate rainfall measure, we'll add it to the total, and we'll increment the number of legitimate rainfall measures we've had in the day so we can compute the average. We'll then compute and print the average. Okay, so let's have a look at that code. So rainfalls, well, we'll make our assignment as we did before, but more realistically, this is going to come from a file that's downloaded off the net or off the web. We'll print out our total, our heading. We'll then print days, readings, total, and average. So these are going to be our column headings. And then for days and days rain in the enumeration of our two-dimensional or nested list of list, we'll set our daily total to 0. So we do this each time we start a new day. We'll set the total number of readings for that day to 0. And then for each of the readings we have within that day, right, so this is our nested loop, if the rain value is greater than or equal to 0, we add it to the total rain for that day. We increment the number of legitimate readings we have, and we're now in a position at the end of that loop, having dealt with all of the rainfall measures for that day, we're in a position to calculate an average, which is just the daily total divided by the number of readings, and then print out, using our nice string formatting construct, the day, the number of readings, the daily total, and the average. All of this, you'll see, is enclosed within our outer loop, our outer for loop. So having done all of this for our first day, we'll then do it for the second day and third day, and so on. Okay, so here's the code with an initialization of some rainfall values, and let's see what happens when we run it. We get our nicely printed out rainfall data for each day, the number of readings we received, the total amount of rain, and our average. But there is still a bug in here. Let's test it with some broken data. So let's say this day has 2 values where the system failed to report an appropriate value. So previously, the second to last day, day index 5, had 4 values. We should now see it's only got 2. Yep. And things are still working. What's the bug then? Well, if we have no successful values for a day, let's think about it. We'll initialize the number of readings for a day to 0. None of our values are going to be greater than or equal to 0. So we're going to end up with num readings equal to 0, because we never get to increment it, because none of our days have a rain value that's greater than or equal to 0, which means when we get down to calculate the average, we'll divide daily total, which is 0, by 0. And anything divided by 0, well, that's an error. So we'll run that and let's see what we get. Unsurprisingly, given what we just thought about, we get a division by 0 error. Okay. So you might like to think about how you'd modify the program to avoid the possibility of that error arising in the case where there are no readings for an entire day. One final thing is that nested code structures are inherently hard. We talked about this earlier with nested conditional statements, if statements, and that's equally true of nested loops. So it's often better to flatten the code and avoid nesting altogether by writing the inner loop as a separate function. And that's what we do in this example here. Rather than having a nested loop that deals with each of the processing the rainfall values for each day, we've written a separate function here that has the job of processing each day's rainfall value. So the argument that's passed in to process daily rain is received as the parameter day's rain. And given a list of rainfalls, return a tuple that is num readings and daily total. That's the job of this newly defined function. So it's going to set the daily totals to 0, it's going to set the number of readings to 0, and then for each of the rain values in the day's rain, if it's a non-negative value, it adds the total, increments the number of readings, and then returns, once that inner loop is complete, it returns the number of readings in the daily total. So we have an outer loop here still. We have the outer loop that increments across the day for each of the day's rains. And we then assign to, using parallel assignment, num readings and daily total, the result of calling process daily rain, which is this function we've just written. And this flattens the code here, eliminates the nested loop, and makes the code much easier to read, and therefore easier to maintain and debug. Okay, thanks for now.